welcome back. Today we got Dan. Dan, help me say your last name properly.
Zaratsian. Yes. Thanks, Jack.
I've always wanted a name with a Z in it because
I like these names. Yeah, I like Z, and so now everything I do has to have a Z in it. If I'm naming things, if I'm looking for cool words, that's important.
Dude, thanks for doing this. We're super fortunate. You're my hero when it comes to advanced analytics, machine learning, all this stuff. I so appreciate you taking time to just be with us today. It's great. Thank you so much.
Sure. Yeah. Thanks for having me. I appreciate it. Yeah.
So I know what you do. You know what I do at Google. I work with our customers on the data platform.
Yeah, sure. So I'm an AI and ML specialist, an engineer specialist, supporting Carolinas and Tennessee. So really any use case that comes up across the region where various organizations are trying to train and deploy machine learning solutions into their products, that's where I come in and I help.
I think when we were talking, what really interests me about what you've been sharing with a lot of customers we run into is like, look, machine learning and AI doesn't have to be just for the propeller heads of this world, the astrophysicists. It can be for normal folks too.
Right. And I think it depends on the organization. Different organizations are at different levels of maturity from an AI standpoint. And then certainly the teams and the people on those teams have different skill sets. So that's why today I think we're talking about some really interesting things, because I'm going to talk a little bit about the no code or low code options of doing ML on Google. But also we'll touch a little bit on the more advanced options for data scientists. And, maybe even you and I can have a spin-off deep dive on some of those more technical, AI platform and Kubeflow type discussions as well.
I think the first topic is AutoML, which sounds like my kind of talk. It automatically MLs it, whatever that means. So can you I don't know how you want to start off, man, but let's dig in on the topic, because I'd certainly want some automatic machine learning. I don't want to do it myself anymore.
Yeah, excellent. So maybe this is a good transition point for me to just share a couple slides, and then I want to show you a little demo. So I'll give some context to what we're trying to do here. So let me go ahead and share my screen. Excellent. So let's focus on AutoML. And to do that, I want to frame this up a little bit. So I think many of you are familiar with different Google applications, right? And so one of the things that we're going to be looking at here is looking at training models to do automatic image recognition. So that's AutoML Vision, but this AutoML capability extends to video, it extends to translation, it extends to just general predictive models if you're trying to predict customer churn, or you're looking at fraud detection or things like that as well. But many of us are familiar with the Google products that we use day to day, and that AI is built into these products, but it's also exposed to organizations in a variety of ways. So you have core building blocks like the ML APIs and the core programming languages for AI and ML on Google. And then you have platform levels. So you could consider AutoML a platform that you leverage, where you bring your data to that platform, you train and deploy a model, and then serve it out in your solutions. And then lastly, we also have solutions. So we're not going to get into that as much today, but that could be our contact center AI solution, call centers and things like that, or it could even be document AI. Okay. And so, yeah, the way I look at this, and Jack, you've hit on this a little bit earlier, was there are different personas that choose to use this technology in different ways. So certainly you have your data scientists that are very up to speed on Python or TensorFlow or a flavor that cares, and they like the hardcore programming tools to where they can leverage their code, but then deploy at scale and train at scale in the cloud.
Yeah, the supposed gods of the technology, right?
That's right. And for those organizations that have those people, they're very lucky, and we want to make sure that we're giving them the most advanced tools to promote their ability and scale it in the way that's needed for solutions. But not everyone's so lucky. So, as you move down the path here, you get into different levels of skill set. Now, that's not to say that these folks aren't doing very productive and meaningful things, but it's to say, they don't have the time or maybe even the need to learn Python, but they want to quickly build machine learning models and integrate them into solutions. Or I even leverage this. So data scientists might even leverage some of these low code or SQL-based ML approaches so that they can quickly build a model and then compare it to their advanced TensorFlow model. So it's an easy way to spin something up without much coding, see how it works, and then use their fancy data science skills to see, can I beat what this AutoML model gave me? And if not, maybe I just go with this low code option. Or if I can, I use it as a benchmark and then try and beat it and enhance it through feature engineering and different algorithms.
So the business analyst, that's where we want to be, right? Like that's where I'm talking about. Like, I get it, man. Like, I don't want to build out a model. Maybe I'll do an MVP in this area, but I can go ahead and build out something fairly straightforward, but still get all the same cool benefits that like those hardcore data scientists are working for, right?
That's right. Yeah, and that's where most of the skills that exist within organizations, right? So whether or not you have advanced skills or you're one of the business analysts or whatever sort of analyst within a company, you can quickly build these models as a MVP, like you mentioned, but you're still leveraging advanced state-of-the-art techniques and models built by Google that you can kind of further enhance with your custom data. So that's part awesome. Of the model training.
Yeah, and you know me, like if somebody else can do the hard work, I will totally allow that. I will totally.
Yeah. Yeah, so let's jump into this. So I like this slide. It kind of frames it up. It puts our ML APIs here. Here we talk about AutoML. Here's our SQL-based machine learning, which is called BigQuery ML. And then our AI platform, which is a whole slew of products that are for advanced data scientists. And you can kind of see that map down here as far as what developer or what analyst or data scientist would typically use. And then if it's a pre-trained model versus a custom model, and if it's your data or our data, right? So in that case, I'm going to jump into specifically the machine learning APIs, which will set up AutoML Vision, and we'll get into a little demo.
Nice. I'm ready.
All right. So ML APIs, we have several of those. These are pre-trained APIs that you can just simply send your data to and get back a response. So an example of that, and I've kind of listed out several of these APIs that we expose. I'm not going to go through each and every one of them in today's discussion. But if we look at Vision and kind of narrow in on that Vision API, let's say that you have an image here. It's an image of a warehouse, and you send it to our pre-trained Vision API. What's going to happen is it's going to go out, it's going to detect the objects, it's going to detect labels here and say, hey, we think this is a warehouse, this is product, this is a factory. It identified the forklift truck. It even can do OCR to extract out text on images. So it can go through and identify those with bounding boxes, extract out the text so we can do things with some of that wording that's embedded within pictures. That's all really helpful. And maybe that's all you need for your MVP or even your end solution.
Yeah.
If you do,
amazing.
That's great.
Yeah, I mean, it's amazing that we can make this happen. So I can't wait to see the demo.
Yeah, certainly. So that's advanced capabilities that we can leverage out of the box. But here's the catch for this. For many organizations, this is way too general. They maybe want to extract the wording, and that's great, and they can leverage that. But identifying that this is a factory or a forklift truck is not really that impactful to what they're trying to solve from a business standpoint. So that's where AutoML Vision, or just our general suite of AutoML capabilities, come into play. You can take through a codeless interface, upload your own images of your factory with labels associated to them, as meaning the targets, setting the target variables, and then let our models crank off. It goes through a model tournament and it'll give you the best response back. So in this case, you still have similar APIs. I've introduced one down here for AutoML tables, which is more for your relational database if you're predicting customer churn or fraud detection, things like that. Nice. And now you take historical data, you feed it into AutoML, let it crank away. It runs a model tournament. It does some feature engineering. It'll do different things depending on which type of data you feed into it versus meaning an image versus a video versus text blob for NLP. But essentially, it'll go off, it'll train the model, it'll detect the best model, and that's what you can push out as an API endpoint, which you can then send files to in real time, meaning like an online model event by event, or you can send data to it in batch and score a full record of multiple records. So.
Cool. Well, I mean, it looks pretty easy on the screen. I mean, we're sending data. AutoML is gonna do all the hard work down at the bottom, right? Like training, deploying, and serving up the model. It then just becomes a matter of calling the API, right?
That's right. That's right. Now, I think there's something to mention here, and I'm going to switch over to the demo, but it's important to know that you shouldn't just blindly take historical data and feed it into an AutoML product, whether it's on Google or somewhere else, and blindly accept the results and move forward. It's important to understand your data. It's maybe even important for you to pre-process the data and do additional things to ensure that the data that you're feeding into any AutoML or really any machine learning or AI training algorithm, it's important to make sure that that data is correctly labeled, that it's in the format you need, that you understand what's going in. And so there's a lot of context there that you shouldn't overlook, but it does take, from an ML standpoint, it does take a lot of that modeling off your shoulders, and there's no need for writing Python code or TensorFlow or anything like that in this particular case.
So just making sure the data that goes in to train this thing is proper, right? Like that's sort of what you're saying, if I'm getting it.
That's right. Yeah, you want to make sure that you're correctly pruning the data and that you understand the business impacts of the variables coming in. Google will crank away on the model for you and output something, but you want to ensure that prediction that you're calling is reliable. And so there's this whole model explainability aspect at the end. There's this whole model monitoring and also just checking the model fit statistics that's generated for you to ensure that you are getting the right model and it's generalizable for new data that's being sent to it.
Yeah, no, I get it, man. Like, don't leave your pictures of chickens in with the ducks if you're trying to guess ducks, right? Like, so
I love that. Yes, yes. And in fact, it's funny you bring that up because in some ways, especially for images, it's good to introduce a bit of noise. For example, if you do have, let's say you're labeling, I like your example of, what did you say?
Chickens and ducks.
Chickens and ducks. So if you do have, let's say that you have a bunch of pictures of chickens and they're in a chicken coop and they're all by the chicken coop. And so, you kind of have that in the background and it has dirt there. But then you take a bunch of pictures of ducks and they're all on green grass and next to a lake, right? So what's going to happen is the model is going to train and it's going to try and recognize these things. But what happens if you take and put a chicken by a lake on green grass? Because you train the model and all of your model training for a duck is by a lake and on green grass, it's actually going to start to recognize the pattern that, hey, a duck is always on green grass and by a lake. So if you put other things by that, there's a chance that it could actually misclassify. So it's important to get a little bit of noise and diversification in your training data so that you can pick up and generalize and create a generalizable model as opposed to something that's very targeted and specific to an environment.
Okay, cool. I've asked a ton of questions, man. Just you can probably just go because I'll think of some more stuff as we go.
All right, so let's jump into a demo here. AutoML Vision. So as you can see, I'm in here. I'm in the Google console. I went down to all the way to the bottom here and hit Vision. So I'm in the artificial intelligence section of Google Cloud Platform. And I'm going to select AutoML. You can see some of the other vision products that we have here, but I'm going to say get started. Okay, and I pre-trained or preloaded some data here for us. So we have I preloaded some images of clouds and was making predictions on clouds. I also have X-rays here and some others. So I'm going to take a look at the X-rays. So I'm going to click into this environment here.
Cool. So this is the actual image set, I guess.
Yeah, so what happens is you load these images. In this particular case, I loaded all of the images into Google Cloud Storage, and then I set a label for them as part of a CSV file. So basically, my CSV file pointed to this image here, and it said there was no finding for this image. In other words, there's no diagnosis for this image. It's a perfectly healthy X-ray. Whereas another one here, if I click on this, there's actually a couple of conditions that it's marked by. And these would typically be something that's flagged by, in this case, being X-rays by a medical, professional that goes through and identifies that there are issues with this X-ray, and here's what they are. Now, what Google gives to us is you can see all these are uploaded for me. And that's part of the upload process. So when I create this data set, I basically say, hey, here's where my images exist. Here's the CSV file with the labels on them. And then it goes through and it kind of cranks away and it uploads it into AutoML Vision, which is the portal that you see here. Now, Google gives us this nice option. In this case, if we want to click on any of these images and interactively adjust the diagnosis or the label, we can do that in here and hit save. So it's really flexible. Not only can I, train a model in this environment and kind of look at my historical data, but I can interactively go in and label images or update the labels if needed.
Could you permission this out? So like, let's say you were in a business and you got a ton of data or a ton of images, but like, for example, with these chest X-rays, maybe we needed a doctor to do the review and the labeling. Can you permission out the console so that they can come in and do the labeling without having the rest of the console around them to worry with?
Sure. Yeah. So Google has this idea of granting certain permissions at the service level and even at within the service or within the actual service level. So in this case, Google AutoML Vision, you can set different roles for certain users that you grant access to the platform on. So certainly we could. We also have a fully dedicated labeling service that you can also upload the images to that service and give access to a variety of physicians or whatever the industry context is. You can give access to certain users that would go in there, label the images, and then those would be, fed into the model training.
That's awesome, man. Yeah, that makes it accessible to the people who really have the expertise,
Certainly, yes, that's exactly right.
Okay, I've interrupted you 12 times. It's just so exciting.
No, this is good, Jack. Keep it coming. So. Now we have historical data. I think we have the foundation that we need for training our machine learning model. So in this case here, I can go to train, and I've already trained a model here. You can see the precision and recall. In this particular case, this is a multi classification model to where we can actually have an image to where the image can be multiple labels in this case. So you can see that in the previous example. So here I can see the full evaluation and model fit if I wanted to, and that's kind of where the evaluate tab goes. But I just want to show you real quick, and we trained a new model. So let's say, Jack, that you and I kind of worked through this. We labeled all the data, assuming that we were qualified medical professionals, which we are not, but let's say we labeled the data, and now we want to train the model. So at this point, no need for writing Python code or TensorFlow or anything like that. We just say, hey, train new model. We come in here, we give it a model name. I can say if I want it to be a cloud hosted model or an edge model, in which case maybe I need to do edge processing to where I can run this model offline or out of the cloud. I can go ahead and do that. So I'll just say cloud hosted for the sake of example. And then I say set your budget. Essentially, this will be a number that you set in order to let the model crank away on multiple iterations. So the longer it runs, the higher number of node hours, the more precise or more accurate the model should become, because it's able to run multiple iterations.
Nice.
So then that's it. Then hit start training. It goes off. It cranks away on our model. It might come back in a few hours. In this case, it'll run multiple iterations. It'll do feature engineering. In the case of images, it'll actually rotate the images, change the color, do different things to help with further enhancing that model accuracy.
I love that, dude. I mean, I love that, we're getting an executable solution here, right? Like that's kind of like I think about my old days of like DLLs and, web services and so forth. Like we took some images, we said, okay, look, this is what good and bad looks like. And now the output from training, looking over all that's an executable component. I love that.
Yeah, absolutely. And Google makes it really easy. Whether it's model training or, as I'm showing you here, it's actually the model evaluation. So in this case, I give you a pretty good example now. For anyone who's familiar with machine learning or even just knows how to read this, this actually isn't predicting very well, because this is called a confusion matrix, and it's trying to identify where the predictions fall based on the actuals versus the predicted. And so what I can see here is that actually we're having a lot of predictions fall into these two categories. And if you look at the data, it's actually because this is where we have the highest number of labeled data. So it's actually an imbalanced data set. And so as a data scientist or anyone who's running this analysis, I can come in and I can say, well, hey, actually I want to rebalance this data a little bit in order to ensure that, number one, we're actually classifying these images in the correct areas, and we're getting a little bit higher accuracy across all of them. But also we can see, where are we misclassifying, and is that a true misclassification, or do we need to go back and look at the labels? And so having these model fit statistics, whether the model is a high accuracy model or it's not doing so well, it's all kind of transparent to us as an end user from a Google standpoint. So I think that's really important to point out to users as well, is that this piece here is really important before you would promote a model into production.
No, that's fantastic. I mean, I've worked on a lot of similar type solutions, and a lot of times when we get to the evaluate portion, like folks just skip over that, and it's like, yeah, you built a model, but I'm not sure it works. So it's great that you explained how easy it is to look at it.
No, and I love pointing this out, because anyone could say, hey, I trained a model on x-rays to identify a diagnosis, but I left this one here purposely. Now I have a different one that has a little bit better prediction, but I wanted to point this out because this is a really good example to where people can't just promote this blindly into production and use it, because otherwise it would be giving you all these wrong classifications, right? So I think that's really important. Now, let's say that this actually did predict well, and a good prediction actually would have a nice diagonal here with more blue across the entire diagonal. So if it actually looked good, then what I can do is I can actually go here and I can deploy the model. So if I can hit deploy model. In this case here, it'll say, hey, do you want it to be deployed? And how do we want it to deploy? So I can go ahead and do that. And what I've already done is deployed a couple models here. So we have this one, which we can go into. Well, let me see here, test and use. And so what we can do is deploy that model and then go off, and it's going to be deployed as a batch endpoint, to where you can just send data to it and get the results back, or we can actually go out and send in a singular image to it and get the results back.
Fantastic, man. That's pretty awesome. I mean, really.
Okay, Jack. So extending this a little further, I pulled up a web application that takes and will leverage that image processing result. So this is a little healthcare app that's built on App Engine, deployed on Google. So if I go to image here and I select an X-ray, so if I, let's say maybe download an X-ray, and then I go ahead and select that X-ray. So I just uploaded it there and I say get diagnosis. So here is actually an interactive application that's hitting that model that I just shared with you all. But now it's built into an application. You can see certain diagnoses that are coming up and the score. And not surprisingly, this one actually shows the two that we saw as being, highest probability. But we also get a couple others here that are potentially interesting to look at if you were a physician and this was an application that you're using for decision support or things like along those natures.
Yeah, I'm glad I'm glad it's me and you talking about ML as opposed to talking about someone with infiltration or infusion or some of those other words I can't guess. It's nice to be on the healthy side, isn't it?
Yeah, certainly. I fortunately and unfortunately, I guess I am not really intimate with those diagnoses, but yeah, this is showing the power of some of the ML capabilities. So yeah, I wanted to share that example.
Out though, right? Like this is a great example of how you could use a solution like this to empower some physicians or people who would evaluate this.
Yeah. Absolutely. And so this is used across, Google's done this in areas for diabetes, where we're actually looking at eyes and, different scans of your eyes to assess diabetes. And we can get extremely high accuracy rates for detecting, various diagnoses for diabetes. And it also works with x-rays, and we've done some other research with cancer. And so I think that in this case here, the important piece is to have a really good training set that physicians go through and moderate. And then secondly, having a clearly defined use case that the organization or whatever sort of agency is trying to solve for.
Yeah. Well, luckily for me and you, we're just pretending today. So
yes,
awesome.
That's right.
And I absolutely love it.
Excellent. Yeah, thank you, Jack. So that's to kind of wrap that up. That is a little walkthrough of AutoML Vision. Now, this extends to other areas as well. It's not just for vision. As I mentioned, it's for video, it's for translation, it's for natural language processing. It's even for we have something called AutoML tables as well. And so in AutoML tables, let's say that you're trying to predict, I have kind of a fun one here that I'll just wrap up on, is that we have this thing for gaming. So I have like a game data set here that has the player that's playing, if they made a kill, what weapon they used to make the kill, where they were on the map, what the map type is. This is a really fun use case. And the goal here is to try and predict what weapon should I use if I want the highest probability of making a kill within this video game. So it's kind of a fun example. And I'm showing this because this is actually a traditional data set that you would use that's coming out of SQL or a relational style database, to where you upload and you're trying to predict just a normal target. It's not a video, it's not an audio file, it's not an image. It's just a standard data set that most data scientists work with. So in this case, you kind of go through the same thing to where you can, go in here. You can, this is a model is getting much better accuracy results. As you can see, I have actually trained 2 different models. And if I look at the model evaluation stats, this looks a little nicer. Here we have a confusion matrix, which this is very nice. It's more aligned to what it should look like. And then lastly, we have something called feature importance. So we can see which features are most impactful in our weapon selection. So in this case, it's interesting that the map type or the game map is actually most impactful. So maybe some maps are more close range, so you use a close range weapon, whereas others are long range, and maybe you use a vortex or electro or some other long range weapon, right?
I've always wanted electro.
Yeah, so this is a fun example, and even in this case, we can kind of test it out, and you see that we have our predictions. This model is actually deployed, so we can do a prediction model, or we can do an online prediction. So in your model, you just send, hey, what game what map type, what server, what game type, etc. And in this case, I'm using all of the variables accessible to me from my data set. But sometimes you actually just want to use a couple of variables. So I trained a model with 9 variables, and this one only has 2 variables. And I wanted to compare the accuracy, which is another technique data scientists used. Less variables is much easier to handle and to push into a model. More, you might get a little bit better accuracy, but are you really going to be able to get the game ID for every game? Maybe not. It really depends on the context or the event date, time, right? It's maybe not something that you want to feed into the model. So you have to think of this from a business context as well.
I love that, man. I want to I want to get my kids to actually do some ML modeling about their game behavior to show how much time they waste on gaming. It'll have 100% accuracy because
yeah. No, this is a fun example. It also showcases that this capability can be leveraged. It's for predicting a weapon in this case, but it can be predicted for, like you said, are you wasting time? It can be looked at customer lifetime value. This type of modeling, AutoML tables can be used for predicting sales and fraud detection in a variety of use cases. So it's multi-purpose for sure.
Yeah, like maybe propensity to buy. That's always a real common one that I hear. Will the customer actually go through with the purchase?
Certainly, yeah.
Fantastic, man. Well, Dan, are we at our line or do you have more? Do we have to wait for another video?
I certainly have more, Jack, but I think we're probably at our time for this session. So anyone out there viewing will probably have to tune into the next one and enjoy our funny jokes and our deep discussion around ML.
Well, they may laugh at our jokes. I'm not sure if I've gotten to funny yet. Dan, thanks so much for doing this, man. I hope you will come back and join us again and share some more of your knowledge, man. Really, really appreciate it.
Of course, Jack. Thanks for having me. Really appreciate it.